business management tasks for setting up the OTS team at Onward. Those experiences understand intense challenges, bringing his entrepreneurial and mindset together to improve the overall profitability of the process group at Onward. Consequently, in 2000, Alok founded Haprotic India at Pune as a 100% subsidiary of Haprotech Canada and managed it efficiently until it was acquired by Aspen Tech in 2002. Post acquisition, Alok was retained as the head of business for South Asia by Aspen Tech, further growing to the role of vice president responsible for Southeast Asia, Australia, and New Zealand, apart from SARC region. This is a brief of his very illustrative career. Now I would like to request Mr. Alok Pandit to start his presentation.
Excuse me.
Yeah.
I just wanted to have 2 points. We already lost 10 minutes.
Sorry?
We have already lost 10 minutes.
Okay.
So
Okay.
you can make your presentation as brief as possible.
Right.
Wherever not necessary, please skip so that we can do some time for discussions.
Yes, absolutely. Agreed.
Thank you.
Okay, thank you. Thank you, Mr. Chairman. Dear friends, it's my honor to be here to talk to you about what digital transformation we are witnessing across the world, across the country, as well as across the industry. So I will take, probably I will skip a lot of slides and I will take only 2 or 3 slides and then directly take an example of how digital transformation can be applied or is being applied in sugar industry. So we'll take one simple example and then I will finish and then we can have some question answers. All right. So first of all, I would like all of you to open your mobile and open Google Chrome on your mobile and type this URL, the link, polev, that is poleverywhere.com/Alok Pandit 336, and you will see this question on your mobile and you can give your answer. In India, an unprecedented digital transformation is taking place. You agree, yes or no? And as your responses will come, the statistics will update in real time here on this screen. So how many people, what percentage of people feel that there is a unprecedented digital transformation? See, we are talking about UPI. I was very excited to see just before lunch how they were registering people coming for lunch, right? No manual entry, no signature, scan a QR code and that is it, right? So that is a terrific example of how digital transformation is helping us, is accelerating things. Yeah, is anybody able to get this? So I wanted to give you a real life experience of digital transformation. I hope this is working. I have tested it. It was working just before lunch, right? So looks like most people are saying or agreeing with the statement. So let's go further. We are talking about digital transformation, and digital transformation cannot happen without data. So we need data in electronic format, which can be transferred obviously from one place to another and can be manipulated using a computer or a mobile. So therefore we need good data. Good data leads to good decisions, and that's what Equinox stands for. You can see that logo, data to decisions. So that's what we basically offer as a service. There are a lot of papers I'm sure you would have read. I will not get into more details, but right from today morning, this is the last one paper I got, this AICHE email, which talks about digital transformation and what digital transformation is all about. So we will skip all this. Just one quick introduction of Equinox. I always say that Equinox is a company that is trying to bridge the gap between the physical world, which is the plant, for example, and the IT world. That's why you see that bridge there. On the left hand side you see a plant, on the right hand side you see an electronic version of that same plant. So that is the digital twin of that plant. How to make it, in how much depth we need to make it, those are questions that depend on what problem you are trying to address. A warning, I always say this, that data gaps are injurious to the health of a plant. So we need to have proper data. When I say proper data, I mean validated data, because there are a lot of time we spend energies and fights whether this data is correct. You know, whenever we are even debating a daily production report with the production manager and the site heads, there is a lot of discussion, lot of arguments, lot of fights. नहीं ये आपने कैसे ले लिया, ये assumption ही गलत है, ये तो हो ही नहीं सकता, मेरे प्लांट में specific energy consumption इतना है ही नहीं, and so on, right? So we require excellent data, right? So that we don't spend time on the quality of data, but spend time on the analysis of data, okay? Today I am not covering how to improve the quality of data. That could be another lecture. There are various techniques by which we can improve the quality of data which is coming from the plant. We will skip this. I'm sure your answer will be yes. Is your day-to-day life becoming more automated with UPI, with banks, with everything? I think we are becoming digital economy, the whole country, and therefore all of us are part of that transformation which is already taking place. Okay, we'll skip this. So just one slide on what is digital transformation. I think all of you will agree with me that when I say digital transformation, basically I mean that everything is being done digitally. In your business, in your factory, in your mill, whatever, whether it is invoicing, whether it is customer meeting, whether it is suppliers payment, whether it is technical services, whether it is data collection, whether it is analysis, performance analysis, you name it. Everything I would like to see being done digitally, okay? Again, we will skip more on this, but this is a slide from Deloitte. Deloitte is considered to be the father who coined the term digital transformation. And in their original report, which they wrote about 10 years back, they gave this definition, basically the same thing which I said, that all functions have to be accomplished digitally. Okay. Now, for that, I already said that the starting point is data. So do we have all the data electronically, right? All kind of data we already talked about. Do you think your organization is becoming more digital? Would you like to vote for this? Again, you can just see your mobile. You will already see this question on your mobile. If that link is on, automatically you will see this question on your mobile. Okay. So I am sure that most organizations are becoming digital. You know, sooner or later they will become 100% digital. But the rate at which the digitalization or digital transformation is taking place is humongous, is very, very fast. So we will skip this. So for me, I always say that you know, any organization should put 2 milestones in front of them. The first one is, let all data be recorded electronically. Where do we start? I mean, if you want to start, go back and start digital transformation of your sugar mill. What is the first thing I would like you to do? Look at what data you are dealing with. Find out whether that data is being handled electronically or not. If not, figure it out how you can handle that data electronically. So that is number one. And then the most important thing, data always has a bad habit that data lies in silos. So the finance guys will have data on their computer, lab quality data will be there lying in the lab computer, and so on. So we not only need the data electronically recorded, but we also need data to be integrated. So a production guy should be able to see the lab data, a lab guy should be able to see the operations data, and so on. So if you can achieve these two things in whatever proportion, it may not be 100% in one day, but whatever you can achieve in these two steps, you would have initiated a digital transformation of your sugar mill. Please remember one more thing, that data has got 4 important attributes, and that we should keep in mind. Number one is the velocity of data. Chemical engineers and the plant people deal with data which is coming in real time. And we are talking of real-time data, which is like from the distributed control system or a SCADA system, data coming at probably every second, a temperature, a flow, pressure. So there is a velocity of data. Then there is a variety of data. There is obviously different forms of data. Some like quality data, some operating variable, state variable, and so on. So there is a variety of data. Uh, volume of data, huge amount of data. We are talking of big data. You can do a calculation on your own. How many tags are there in your plant, and multiply those tags with the frequency at which data is being collected, and you will see a typical sugar mill of 4,000 tons capacity will be generating nothing like than a 2 or 3 gigabyte of data per day, right? Are we really looking into that data, or we are just collecting the data, making it a manual data sheet and filing it, right? And that's where I think the digital transformation will help us. Okay, again, I will skip all these things. These are some of the techniques which are useful for us as far as data collection is there. So for the want of time, I will skip this. Can you please put on that Excel file now?
Yeah. Hello?
I will do it.
एक्सेल फाइल ओपन करा थी.
हाँ वही है, मैंने ओपन किया उसको डिलीट कर वो कर देगा डुप्लीकेट कर.
Is this the same?
Okay, let me operate it from here. I think it is I don't want it.
So you have a mic, right?
No, it's okay. I think you can listen. You can hear me, right?
You mic.
Okay.
Hand mic there.
Hello? Oh, great. Okay, so let's look at, I tried creating a synthetic data set. This may not be a real data set of a sugar mill, but it is very close to the kind of data that you guys must be collecting. So for example, you can see here, the first column, the first column here is the capacity, that is the total amount of cane crushed on that day. Then you have sugar cane pole percentage. Then you have added water flow rate. Then you have what is that, mass volume? Mixed juice flow rate. Then you have the BX content of mixed juice. Then you have mixed juice pole content, and so on. So this is a kind of operating data. By the way, my interest here in talking to you guys is not to do heat and mass balance for design. I think a lot of my previous colleagues spoke about how heat and mass balance is used for design, which is, the standard thing. My interest is how do we use heat and mass balance on a day-to-day basis, on a shift-to-shift basis, and use that to infer the performance of the plant at that moment, in that shift or on that day, right? So that is what I'm trying to show you. So now this is the data we have. Let's say now if I want to look at just the 1 unit operation of the mill, which is the first one, which is the mill. So here what I can do is I can select the date. So let's say I have data actually for 30 days. So the moment you select the date, the heat and mass balance is already recorded on that graphic. So for any day you will be able to check what is the sugar yield. For example, interestingly, on this particular day, you will notice here. Okay, let me zoom this little bit.
You can go to presentation.
No, this is Excel file. So you see here that the sugar balance is not matching. On that particular day, whatever data has come from the plant, if you do a sugar balance, you are off by 5.6%. On some other days, if you go to some other day, for example, let's say the 2nd April data, then you will see sugar balance is further off, almost 11% off, right? For first day it was off by 5%. Tell me, is this a real situation? Do you see this kind of imbalances? I'm sure this is, right? And now the question is that how are you going to balance it? So I'm sure what people do is, isko thoda change kar do, isko thoda change kar do, and it's a very subjective exercise, right? Whereas what I am presenting you is a scientific method of closing the mass balance and energy balance, okay? The way the whole model is set up is that we take the milling side of the operation, we see how much bagasse is generated. That bagasse, part of it is going to your boiler house, and then finally you're generating part as steam and part as power. And that steam is also used to drive other crushing mills, etc. And finally there is a last amount of steam, almost at 1.2 kg bar gas, which is finally going for your evaporation operation. So this whole thing is integrated, right? So at any point of time, if you are really digitally transformed organization, then anybody in your company or any engineer in your company will be able to see this. The last thing I want to talk about is, so what do we do with this? I mean, how does it help us end of the day, right? So now here what you will find is, interestingly, you notice this tab, you may not be able to see it there, but it says design HMB. So that is the design heat and mass balance. So for that day's operating data, if I use that as the basis and check it against the design, which the designer would have already given me, right? Then I will see the design picture, that this is how the plant would have behaved. So it shows me design efficiency, boiler ka 65% tha, turbine ka 70% tha, but those are fixed. Those were fixed by the designer, right? But today, what is the efficiency? I am more interested in that, right? So there is an operating envelope. So this operating envelope here is the operating heat and mass balance. And this operating heat and mass balance shows me the real-time efficiency of the boiler today for this set of data. Whatever date you have selected, 1st April, 2nd April, etc., you will be able to see what is the efficiency of boiler, what is the efficiency of turbine, how much waste is generated, how much sugar, what is the yield, and so on, all those things. And incidentally, I have not shown here because I also didn't have much time, unfortunately, but all the calculations that are being done actually are sent to a database. Okay, so the calculated parameters are also stored in the same database where the operating parameters were stored. I showed you the raw data on one sheet, but on the right hand side of that sheet only, I can actually write, or on a SQL database, I can write all the calculated parameters. Here you can see the red parameters are the plant values, these are the raw plant values, and on the right hand side are the black values, which are the calculated values. So now there is no jagla, everything is in crystal clear. This is what the plant is saying, this is what the design is saying, this is when you remove all the noise from the data, that means inconsistencies of the data, then this is what the plant performance is. Now nobody can question me. I can confidently say that this plant is running at this efficiency, and this is the trend of this efficiency. Over last 7 days, 10 days, 30 days, this efficiency has fallen from 72% to 69%, 68%. What are we doing about it, right? You need to close that loop, right? The data analysis will show you what is happening, but finally somebody has to take a decision and close the loop. So I think with that I will stop. There are a lot of other slides I can get into. I don't think it will be much useful. Thank you very much.
Thank you, Mr. Pandit. It was a very eye-opening subject. And we tried to open out the subject during our last convention about AI. Okay. But now this is one stage ahead. And I'm sure the sugar industry will certainly benefit from this.
Now, house is open for interaction.
I hope I have honored your time limit.
Thank you so much. That's why I said first thank you.
Okay, thanks.
Come on the dais.
Okay.
I think a digital twin is the synonymous with the
Yes.
simulation technique.
Yeah, so simulation. Can I write?
Yeah.
See, by the way, these terms are becoming more and more common. Digital twin, etc., etc. in essence, a digital twin is nothing but a heat and mass balance calculation of the whole plant. Okay, I can implement it in some standard software, which could be ChemCAD, Aspen Plus, DWSim. There are so many of them. DWSim, by the way, you know, is a open source software, so it's a free of cost. Anybody can download it, and you can start using it tomorrow. Others are, you know, price softwares, or you can set up a digital twin in your own way, like in Excel, as a lot of my previous speakers had shown very detailed Excel files doing design calculations, right? So that is also digital twin. What I am showing you is also digital twin, because typically I am taking the operating data coming from the plant and doing the heat and mass balance to do the performance analysis. Of course, once this kind of Excel is set up, you can also do what is more important, is what is called sensitivity studies. So if you change this bagasse flow rate by 1%, what will happen? If you change steam demand by 1%, what happens, etc., etc. Because the whole model is set up and it is linked to the plant data at any point of time.
Thank you, Mr. Pandit.
Very good presentation. I request the chairman to felicitate the
There is
speaker.
a question, I have a small query.
Okay.
Yes, sir.
What is the prerequisite to start with digital twin?
Yeah. So,
Suppose one sugar factory wants to start this.
yes.
What is the prerequisite?
Yeah. So as I said, you know, the very, very first thing is that, are we having data in electronic format? Are we collecting data in electronic format? So when you go back, just look at all the functions. Okay, let's look at only chemical engineers. So we are looking at operating data, we are looking at design data, and we are looking at the lab quality data. So at least these three data sets are available to me electronically. I'm pretty much ready to start. Now, if it is not available electronically, then I may have to do a step before that. That means I may have to do some instrumentation, I may have to set up a data acquisition system, and so on.
Thank you, Mr. Pandit.
Yeah. I think there is one question.
One more expectation from you at this DSTA platform.
Yeah.
Artificial intelligence has to be applied in the sugar industry, and if you are aware, in the next DSTA convention, have your good paper on the subject.
Okay, so again, because of short of time, I skipped a lot of material. My last 3 or 4 slides were on analytics, artificial intelligence, soft sensors, how all these things are being used in chemical plants, refineries, sugar plants, cement, and so many other plants, right? But
Thank you, sir.
we just skipped it. Okay, so I was expecting that question. If the question is, has it been implemented by us in sugar plant, the answer is no, because unfortunately or fortunately, we are not dealing in the sugar plant. But if the question is, has it been implemented in any plant where we work? Yes, I can take you to the plant and show you it working. Oil and gas, chemicals, refineries, petrochemicals, all those plants, right? But yeah, sugar plant, at least we have not done. But steel also we have done. Tata Steel we have done one site. But okay, we may not have done it. But if you look at the published literature, there are hundreds of papers. I downloaded hundreds of papers, and Gharpure sir also shared a couple of papers. I think he was doing his own reading of digital twins. And we found there are papers, Korea, Indonesia, I mean countries which are probably not as technically advanced as India, I would say, like Indonesia. They have done excellent digital twin in a sugar plant, and they have published 2 or 3 papers. Artificial neural network, crystallizer. Crystallizer is an excellent example where we can apply a digital twin in a sugar plant, right? So I'll be happy to discuss that and, you know, take it up further. Yeah, 2 or 3 papers, right?
Those AI slide 2 or 3, can you show quickly?
Yeah, I don't know, sir.
No, it's all right. Show, you can show. No problem.
Okay, then I will just go to that. Next time I think they'll change
Obviously, a digital twin is a new concept to the factory people, but they must be aware of the simulation technique. Since digital twin is the synonymous to the simulation technique, you can know very well the little difference between the simulation technique and a digital twin. Very nice presentation, Mr. Alok Pandit.